Did you know that in the vacuum of space, sound can't travel? Entire worlds can still hum with artificial gravity. As you drift here, weightless and unanchored, that thought hangs with you like a soft echo in the dark. Your eyes follow the faint shimmer of distant newborn stars, and for a moment you wonder where humanity will actually live one day. Not on untouched alien worlds, but on ones we build ourselves. Out here, the idea feels strangely natural: floating cities, spinning habitats, whole artificial worlds, turning gently in the quiet. Your vessel barely whispers as it moves, console lights glowing warm against the cold. And as you watch them, you can almost imagine calling one of those massive human-made worlds home. Over the centuries, people have dreamed up these impossible creations, each larger and bolder than the last. And now, drifting in this slow, silent glide, you join that long line of dreamers. You shift a little in your seat as the ship corrects its course, so subtle you feel it more than you hear it. The air carries that familiar metallic hint, reminding you just how small your pocket of life is in all this emptiness. But there's no hurry tonight. You're here to wander through these colossal possibilities, to let each idea rise and settle in your mind like a passing star. It's a lot to take in, but that's part of the wonder. When you breathe deeply, the scale of it hits you. Megastructure can mean so many things that defining it becomes its own quiet puzzle. In simple terms, it's anything massive and human-made, but most visions are habitats meant to hold entire communities, complete with their own little ecosystems. Some are surprisingly practical, close enough to feel almost reachable. The drifting O'Neill cylinder, spinning a whole world inside a shell. The Stanford torus, a ring where gravity is born from rotation. Others are pure ambition: flat planets, giant cubes, mind-bending shapes that challenge the universe just because we dare. And beneath many of these ideas sits one elegant force we'll unravel soon: the strange, beautiful magic of spin gravity. To guide our gentle exploration through this bewildering array, we'll adopt a simple, alphabetical approach, a calm progression through the possibilities. It just feels right, a steady, predictable path through the unpredictable. We'll also take a moment to understand those crucial engineering tricks that make these colossal dreams even remotely feasible. So, let's begin with one of the most fundamental principles for building truly gargantuan constructs: active support, before turning our attention to one of the most astonishing megastructures ever conceived, the Alderson disk. Active support isn't a structure itself, but rather an engineering marvel, a method to construct things so vast that no known static material could possibly bear their own weight. With the way it is so, IBN. The pucken of bound I bow open mess band to band to you to the go with you bob of I do you I love to I do to why you have to you we do with the dot come with the to fly with that both have to go as probably by the that's we you are data I'm viewed to hooked at my god the purpose are more how other youth I die on if it were but to be to if them but a cut you of court kid award if you if I often said if the feedment It's a conceptually simple analogy for an incredibly complex idea. For structures like an orbital ring, this might involve incredibly fast-moving strands of superconducting metal, magnetically confined and continuously accelerated within a stationary sheath. This internal kinetic energy grants the external structure an astonishing, almost arbitrary, strength and rigidity, holding it taut against the vacuum. A marvel, really. From this foundational principle, we can begin to fathom structures like the Alderson disk. Can you picture it? An immense, flat, disc-shaped world, so vast it completely encircles its star. You could live on both its top and bottom surfaces, gazing inward at the brilliant core or outward into the endless starfield. This extraordinary concept was first imagined by a scientist deeply embedded in science fiction, and his vision was truly colossal. Around our own sun, an Alderson disk would stretch from the fiery embrace of its star all the way out to the frigid frozen depths of Pluto's orbit, a flat plate with a central aperture for the sun. This colossal disk would possess a mass so staggering it would utterly dwarf its central star, 3,000 times the mass of our own sun, easily 1 billion Earths. Its scale is almost incomprehensible, a feat of engineering that makes one's head spin with wonder. But even with active support, two critical challenges emerge. First, maintaining its shape against the immense gravitational forces, preventing it from collapsing into a flatter plate or crumpling into a sphere. And second, the light. Most of the star's energy would simply pass above or below the disk, leaving its vast surfaces in perpetual twilight, growing ever dimmer and colder the further you travel from the warm central opening. Always a catch, isn't there? The resulting environment would be a world of extremes, a warm, habitable zone close to the star, rapidly transitioning to frigid, unlivable outer reaches. It's a stark reality for such a grand design. Yet, even here, human ingenuity finds a way. Some imaginative minds have proposed a rather playful solution to gently bob the central star up and down within its aperture, allowing it to periodically illuminate both surfaces of the disk more directly. A dancing star, if you will. It sounds almost whimsical, but given the star is the smaller object in this cosmic arrangement, it's a technically feasible, if wildly ambitious, idea. Perhaps a soft, slow sway to bring dawn and dusk across those endless plains, through its very heart. A path almost impossibly unique. Yet, even such a grand design struggles with the simple rhythms we take for granted. A natural 24-hour day, or the subtle dance of seasons, would require an almost ceaseless effort to maintain. This colossal vision, this Alderson disk, truly belongs in the realm of mega-engineering marvels, a testament to humanity's boundless imagination. To keep it from simply collapsing under its own immense weight, imagine layers upon layers of colossal rings, each one gently wider than the last, all quietly spinning at their own perfect speed. These nested circles, stretching further than the mind can easily grasp, each contribute to holding the disk together. Even as the central star's pull becomes less significant than the collective gravity of the inner structures themselves. Above and below these intricate spinning pathways, vast plates form the habitable surfaces, held apart by immense, silent pillars, mighty atlas-like supports that prevent the entire world from being crushed. And to keep our vital breath, our precious water, and even the very land from hurtling towards the center, subtle segment walls rise up, perhaps disguised as majestic mountain ranges, while vast, silent pumps deep below gently guide everything back into its proper place. You can almost feel the soft vibration through the hull, a distant hum resonating with the sheer scale of such an endeavor. The engineering gets even more fascinating when you consider the gravity. by carefully altering the mass and density within those hidden rings. It's possible to gently counteract the central star's pull, ensuring that gravity always feels wonderfully, reassuringly down beneath your feet, no matter where you stand on the disk. And for power, imagine the innermost ring, closest to that distant star, shimmering as an enormous collector, drinking in its light and warmth. But how to create a day, a night, or the shifting beauty of seasons on such an unfathomable scale? That's where colossal mirrors and vast shades, like silent celestial dancers, come into play. They would be positioned far above and below the star's poles, reflecting sunlight onto the disk or casting vast shadows, mimicking the slow spin of a familiar world. These reflective giants, perhaps with tilted bands or segmented wedges, would paint the landscape with dawn and dusk, bringing warmth or shade as needed, weaving the illusion of time passing, of seasons turning. It's an astonishing concept, isn't it? Something born from the wild dreams of science fiction, yet theoretically possible, a continuous, Earth-like surface of such immense size, dwarfing even a Dyson sphere. You can almost feel the gentle shift in the recycled air, imagining the vast, controlled climate of such a place. Now, let's bring our thoughts a little closer, perhaps to something you might encounter on your own journey. Picture the arcology megatower, not just a building, but an entire, self-contained ecosystem reaching for the heavens. We're talking about structures so impossibly tall and wide that they dwarf even the grandest skyscrapers of old Earth. They wouldn't just be powered from within, they'd purify their own air and water, and even grow their own food, often depicted in tales of crumbling, grimy futures. You might just as easily find them as gleaming bastions of utopia, or perhaps self-sufficient enclaves, almost like a gated community against the backdrop of an alien world. Think of a space outpost, a silent sentinel, but standing proudly as a tower, completely self-sufficient. That would be the very first true arcology, wouldn't it? Though it needn't always pierce the sky. Some might sprawl widely across a landscape, or even burrow deep beneath the surface, hidden from the void. The word itself, a beautiful fusion of architecture and ecology, originally simply meant any self-sufficient, environmentally conscious design. It was only later that the iconic image of the colossal skyscraper truly captured our imagination, transforming it into the arcology megatower we imagine today. Feel the faint engine hum, a steady reassurance as we ponder these architectural giants. And then there are the arcships, vessels of hope, carrying the very essence of life across the vast, silent chasms between stars. The very concept echoes the ancient tales of Noah, but on an interstellar scale. Picture a truly enormous cylinder, a world unto itself, propelled through the darkness. Inside, beneath artificial suns, you'd find entire towns, sprawling gardens, verdant farms, even carefully preserved zoos and natural habitats, an entire terrestrial biosphere sustained for generations until it finally reaches a distant, waiting world. It's a journey measured in centuries, where the energy required to power these contained worlds for untold lifetimes is still utterly dwarfed by the sheer force needed to accelerate and then decelerate such a monumental vessel. These silent giants are often known as generation ships, carrying not just people, but an entire legacy forward. But there's another kind, much smaller, often overlooked in the grand scale of megastructures, the seed ship. These humble vessels carry not living, breathing ecosystems, but frozen samples, or perhaps even digital blueprints of life forms. ready to be resurrected on a new world. They are quiet carriers of potential rather than bustling mobile cities. You might need a moment to just float here, letting the scale of these voyages sink in. Isn't that just like space? Always holding a promise for new beginnings. Speaking of new beginnings, or perhaps just ensuring the old ones continue, we sometimes speak of artificial suns. These aren't always grand, actual stars created from scratch, though the universe permits such wonders. Perhaps using unusual materials like pure deuterium for a smaller, more controlled stellar heart. Or perhaps they're living stars, carefully managed with star-lifting apparatuses, gently siphoning off elements to extend their lives, allowing them to be refueled. Sometimes, an artificial sun could even be something truly exotic, like a black hole carefully harnessed, drawing power from infalling matter, or even the enigmatic Hawking radiation. More often, when we talk about them in the context of megastructures, we mean the vast, controlled lighting systems that illuminate our habitats. Imagine a rogue planet, unlit and wandering through the cosmos, suddenly brought to life by an orbiting artificial sun, creating a geocentric world where light comes from a man-made source. Or perhaps it's a series of colossal sun towers, rising like ancient monuments from the alien landscape, bathing everything in their warm, engineered glow. The soft glow from the navigation console washes over your hand, reflecting the distant, fabricated light of such a concept. And then there are asteroid colonies, not megastructures themselves, perhaps, but certainly the perfect stage for them. When you consider that these minor worlds outnumber traditional planets by thousands to one, you begin to grasp their immense potential. They are the scattered stepping stones across the cosmic ocean, each one a unique opportunity, a blank canvas awaiting transformation. Imagine the quiet hum of life support systems nested deep within a hollowed-out asteroid, bathed in the soft, cool, recycled air. The subtle movement of the ship reminds you that even now, we are drifting towards countless such possibilities, each a potential haven. These colossal structures, designed not just for shelter, but for entirely new worlds. You see, the most common approaches often involve utilizing what's already out there. Imagine an asteroid, that unassuming chunk of rock, drifting through the silent void. It's a perfect candidate for a hidden haven, tucked away from prying eyes, naturally shielded from space debris or any unwelcome visitors. But don't picture some sci-fi fantasy where we just spin the whole thing to create gravity. Most asteroids are just loosely bound cosmic gravel, barely holding themselves together. Instead, we'd meticulously hollow it out, inserting a robust, thin inner shell for structural integrity, and then build our rotating cylinder habitat safely within its heart. You can almost feel the gentle thrum of life support, a faint echo of engines deep inside as you drift through such a quiet, hidden world. Larger asteroids, if we ever find ones stable enough, could become true marvels housing hundreds of individual cylinder habitats, like a string of pearls. Or, in the distant future, perhaps even evolve into vast, intricately networked shells of living space, far wider than the original asteroid ever was, glowing softly from within. We call these buckyhabs, a truly grand expansion on a humble beginning. Yet, even more ambitious are the Atlas pillars, named for the ancient Titan who bore the sky itself. You might need a moment to just float here and truly grasp their scale. Envision towering supports, designed for Matryoshka shell worlds, those incredible concentric layers of land and sea, each artificially lit, maximizing every bit of mass for gravity and living area. It's an engineering dream, isn't it? These pillars, potentially crafted from some impossibly strong, almost mythical material, would more likely feature internal tracks, quietly humming with magnetically accelerated materials, maybe even superconducting pathways, demanding almost no power or cooling, just pure, elegant efficiency. The gentle vibration of the ship's hull carries the faintest hint of distant power generation, a constant, comforting presence. Imagine looking up through layers of manufactured sky, seeing other habitats clinging to the pillar like leaves on a colossal tree, or walking along spirals etched into their outer surface, journeying effortlessly between entire worlds stacked one upon another. It's a dizzying thought, yet utterly captivating. Then there's the sheer audacity of a Banks orbital, named for the visionary author Iain M. Banks. This immense ring habitat, sometimes called God's bracelet, is unique. Its required tensile strength, frankly, defies any material we currently know. But imagine it, a ring so vast, its rim walls are shorter than its width, allowing an asterisk open-air, asterisk environment. You could fly your ship right into its atmosphere, landing gently on what feels like an artificial planet. The subtle shift in gravity, a pleasant surprise. Isn't that just like space, always finding a way to surprise you with something utterly unexpected? Its genius lies in its natural day length. This colossal ring rotates just once per day, its orbit around a star subtly tilted, allowing the sun to shine naturally on its interior, painting the sky with genuine sunrises and twilight, even simulating seasons. The recycled air within our own vessel feels crisp as we contemplate such a vast, breath-upon space, while its width can vary. The purpose that perfect natural means, the living band, is considerably thinner than the ring's immense diameter. For every 48 kilometers of width, you're adding another Earth's worth of surface area. A Terran Banks orbital, mimicking our home world's gravity and day, would span a staggering 1.84 million kilometers in radius. Just think of that, a colossal embrace around a star. Of course, we could build Martian Banks orbitals, smaller at about 700,000 kilometers in radius, or even Venusian or lunar ones, though those would need to be far, far larger due to their incredibly long days. Why does the universe always do this to you, presenting scales that stretch the imagination to its breaking point? Our ship drifts lazily now, console lights casting soft reflections on your face, a distant nebula, a smudge of ethereal color through the viewport, and in this calm, we revisit older, equally grand ideas. The Bernal sphere, for instance, a concept from 1929, a hollow, rotating spherical shell. The original design was about 8 kilometers in radius, offering over 800 square kilometers of interior surface, enough for tens of thousands of souls. It feels cozy, almost intimate compared to the Banks orbital. Spin provides the gravity, strongest at the equator, vanishing entirely at the poles. A fun little sensation, floating effortlessly. If you venture too far up or down, you'd likely find ring-shaped tiers inside, widest near the equator, creating flatter, more usable land. It's a timeless classic, a truly ingenious solution to create a world within a world. But some minds look beyond even these immense structures. Paul Birch, a visionary who gave us the orbital ring concept, envisioned using such supports to build utterly massive hollow shells, filling them with matter to create artificial planets. We call these shell worlds here and he even suggested constructing them around giant black holes, like the colossal one at the very center of our own galaxy. When built around a regular black hole, we simply categorize them as mega-Earths. But for those truly enormous galactic core black holes, well, we reserve the title Birch Planet in his honor. The black hole at our galaxy's heart, a staggering 4 million times the mass of our Sun, represents a gravitational anchor beyond anything we can truly grasp. It's a quiet awe, a profound wonder, as we simply drift, bathed in the faint starlight that still manages to reach us, reflecting off the polished hull. The subtle, constant movement of the ship is a gentle reminder that we are merely observers, privileged to witness such unimaginable concepts. And so, as we drift silently past the shimmering, distant glow of a nebula, imagine for a moment a colossal shell, so vast it dwarfs any world we've ever known. This isn't just a planetary surface, it's a single layer, crafted perhaps by untold generations of engineers. Yet it offers an astounding 1.3 trillion times the living space of Earth. And believe it or not, that's considered rather modest. Some of these incredible birch planets are designed with hundreds of such layers, reaching a mind-boggling quadrillion Earth-sized living areas. Just picture the sheer expanse of it all, stretching out beneath you, a tapestry of artificial worlds within worlds. The soft vibration through our hull feels almost like a whisper, carrying secrets of impossible scales. These monumental structures, sometimes called birch planets, often embrace the immense gravitational pull of a black hole at their core. You see, you could pour an entire galaxy's worth of stellar mass, nearly 1 trillion suns, into a black hole before its event horizon would swell. Beyond the point where its gravity matched Earth's surface pull. This represents the ultimate boundary for a birch planet, aiming to replicate Earth-like conditions without crossing that cosmic threshold. And while the tidal forces around such a behemoth black hole would be surprisingly gentle, it does lead one to ponder, could someone, somehow, build asterisk inside asterisk that horizon, effectively vanishing from our observable universe? Nothing to worry about, probably. Although, the universe has a way of complicating things. The sheer warp of spacetime, known as frame dragging, would likely make building to that theoretical maximum size quite the cosmic challenge. Yet, the ambition knows no bounds. A truly maximal birch planet might encompass multiple galaxies, featuring thousands of layers, ultimately providing over a sextillion billion Earths worth of habitable space. It's so immense, in fact, that you don't measure its width in kilometers or even light minutes. The larger ones span an entire light year. Isn't that just like space, always pushing the boundaries of what we can even conceive? This makes the birch planet the largest known megastructure permitted by our current understanding of physics, offering a continuous, Earth-like living area on an unparalleled scale. Your console lights flicker softly, a quiet contrast to the unfathomable darkness outside, a reminder of our cozy, contained reality within this vastness. Within these layered worlds, a curious phenomenon occurs. Time itself can begin to behave differently. On the lower levels, closer to the profound gravitational well of the central black hole, time might actually run significantly slower than on the higher, outer layers due to relativistic distortions. Imagine entire civilizations living at different temporal speeds. These habitats truly become isolated universes, consuming nearly all the available matter in their gravitationally bound region, sustained for eons by the slow, deliberate feeding of mass into the black hole. This process generates the immense power needed for their artificial lighting, perhaps through magnificent suntuars, bathing entire layers in perpetual warm glow. The recycled air feels crisp, a small bubble of life amidst such grand design. Leaving such a world, however, presents its own unique challenge. While incredibly easy to approach, a birch planet demands an enormous escape velocity, making departure a monumental feat. It's a testament to the ultimate ambition of a civilization, perhaps even a potential fate for our own Earth, or any culture that masters automated mining, gradually expanding their home world by drawing matter from across an entire galaxy. Some multi-layered birch planets even achieve a kind of self-sufficiency, thickening their lowest levels and precisely spacing subsequent ones to generate their own gravity, entirely independent of the central black hole. We call these remarkable constructs supercells. You might need a moment to just float here, letting that sink in. Now, let's shift our gaze from colossal shells to something a little more contained, yet still breathtaking in scale. The Bishop Ring. Imagine a vast, rotating ribbon, born from materials of incredible strength, like carbon nanotubes and graphene. Proposed by Forrest Bishop back in '97, this habitat would unfurl with a radius of 1,000 kilometers and a width of 500. Visualize a landmass comparable to India, roughly 3 million square kilometers of internal land and sea, an entire continent-class world spinning gently through the void. You can almost feel the subtle shift in gravity as our ship makes a minor adjustment, a whisper of the forces that would shape such an artificial world. This immense ring, large enough for an open-air environment, although many debates persist about the merits of enclosing it completely, would spin once every 33 minutes to create a comfortable, Earth-like gravity that's slow enough, perhaps, that the distant stars wouldn't blur into a nauseating streak during its night cycles. Of course, a normal day would still require an artificial sun, whether through cleverly positioned mirrors or vast powered lighting arrays. We can imagine tethers, like spokes on a grand cosmic wheel, reaching up to a central hub for easy transport, and perhaps even sleek vacuum trains hurtling along the outer rim, a prime launching point for spaceships, rotating at over 3 kilometers per second. Quite a clever way to save on fuel, don't you think? The faint engine hum of our own vessel is a gentle lullaby compared to the potential symphony of such a vibrant, spinning world. Such a marvel would be more than just a home. Bishop rings could comfortably shelter 1 billion souls, or even become sprawling nature preserves, vast enough to protect even the largest, most delicate ecologies. Imagine pristine forests, towering mountains, and deep, shimmering oceans, all contained within a perfectly balanced, spinning world. The very thought evokes a quiet awe, doesn't it? A place where humanity could thrive, or where the wild heart of nature could beat uninterrupted, a tranquil sanctuary in the infinite expanse of space. But how do you even begin to craft such colossal habitats, especially those that need immense gravitational pull? That's where the ingenious concept of a black hole gravity generator comes into play. Whether artificially created or even utilizing natural ones for those truly gigantic mega-Earths, black holes offer a unique solution. Because they're essentially point-like objects, they sidestep the usual density problems of conventional matter, allowing even a modest asteroid to possess Earth-like surface gravity, creating a mini-Earth, or imparting that same comfortable pull to truly enormous worlds, like supermundane planets. It's a remarkable feat of cosmic engineering, isn't it? The amount of surface area you can have at your desired gravity simply scales with the black hole's mass. Double the mass, double the habitable surface. Your starlight reflections on the console seem to dance with the sheer wonder of it all. These incredible gravitational anchors don't eliminate the need for mass altogether, but they do revolutionize what kind of mass you can use. Instead of precious carbon or iron, you can feed these black holes with incredibly abundant, less useful materials like hydrogen and helium, or even, theoretically, that mysterious dark matter that makes up the vast majority of the universe's heft. And while dumping these elements into a black hole won't fuel fusion reactors, the sheer energy unleashed by that process tends to be an order of magnitude higher than fusion could ever produce. A truly elegant solution in its own way, offering both gravity and immense power from the most common substances in the cosmos. The subtle warmth from our ship's systems is a gentle reminder of the energy that keeps us moving, a pale echo of the power within a black hole. And speaking of power, black holes themselves are incredible cosmic engines, capable of generating energy in several fascinating ways. Smaller ones might emit the ethereal glow of Hawking radiation, a quantum whisper of energy from the edge of existence. Larger black holes, those grand galactic hearts, power themselves by drawing in matter, which then accelerates and collides in a fiery, spiraling accretion disk, radiating immense energy outwards. In essence, nearly all the mass energy involved is converted into usable power. Imagine tapping into such a raw, untamed force, an incredible engine of the cosmos. And it's this boundless energy that forms the backbone of these future marvels. You float now in a quiet chamber, the soft glow of console lights casting long, shifting shadows across the controls. Beyond your viewport, the universe unfolds in a silent, breathtaking tableau. We harness so much out here, don't we? So much raw power. Imagine, if you will, the quiet heart of a distant civilization, perhaps even your own habitat, drawing its lifeblood from something as profound as a miniature black hole. It hums with an efficiency that makes even the most advanced fusion seem quaint, providing not just light and warmth, but that gentle, familiar pull of gravity beneath your feet. A steady, unwavering force, promising billions of years of comfortable, recycled air to breathe, of sunrises orchestrated precisely, year after year after year. This isn't just about endless energy, though that's certainly appealing. Think about the scale. A single compact source, barely visible against the starfield, yet capable of generating the gravitational embrace for an entire city-sized habitat. The faint tremor you feel through the hull, a soft, almost imperceptible vibration, could very well be the distant echo of such a marvel at work. It's a foundational concept, really, not just for power, but for the very structure of a future where micro-black holes might anchor entire worlds, serving as their literal center, a silent, powerful heart. It's quite the thought, isn't it? As we drift further, leaving behind the abstract power sources, let's turn our gaze to other ways of inhabiting this vastness. Imagine descending not to solid ground, but into the welcoming embrace of a world's dense atmosphere. You might find a bubble hab, a marvel of buoyancy, gently bobbing in the perpetual clouds. It feels a bit like being inside a colossal blimp, doesn't it? On worlds like a cooler Venus, where the air itself is heavier than Earth's, your own familiar oxygen and nitrogen can become the lifting gas, holding you aloft. A subtle sway, a gentle shift in the perceived gravity, as the entire structure breathes with the planet below. Perhaps these aren't even built, but grown. Organic marvels shimmering softly in the filtered sunlight, like an immense, buoyant coral reef or a sky whale drifting through a planetary ocean of gas. Think of the quiet wonder of living within a living structure, where the walls might pulsate faintly, sustaining you. Nothing to worry about, probably. The recycled air within tastes clean and slightly sweet, a constant reminder of the gentle, closed-loop life aboard these floating havens, where you might need a moment to just float here, watching the cloudscapes pass by. Then, there are the architectural dreams that defy simple description, like the colossal buckyhats. Imagine 90 individual cylinder habitats, each a world unto itself, meticulously linked together to form a structure reminiscent of a gigantic, intricate soccer ball. From this distance, it gleams faintly, a network of shimmering tubes against the cosmic black, each intersection a bustling hub. It's a testament to planning, a commitment to shared space and security, providing a vast, almost unimaginable amount of living area. The subtle thrum of distant systems reaches you, a deeper vibration through your ship's frame, hinting at the sheer scale of the interconnected life within. This geometric wonder isn't just about maximizing space, it's about intelligent design. Imagine the protection a thick, spherical outer skin provides, deflecting stray particles, radiating excess heat into the void, or harvesting sunlight across its immense surface. And what if there were more? Layers upon layers, perhaps a smaller soccer ball nestled inside the larger, connected by yet more pathways. Isn't that just like space? To offer such elegant, complex solutions for living on a grand scale, pushing the very boundaries of what we conceive as home. Of course, not everything built out here is purely practical. Sometimes, the universe inspires us to create simply because we can. These are the BWC megastructures, intriguing, sometimes wildly impractical concepts that exist more for prestige or the sheer joy of novelty. You've seen them, haven't you? A perfectly cubic planet, perhaps, or a disc-shaped world spinning serenely from your viewpoint. They are striking oddities, beautiful in their deliberate defiance of natural form. Why does the universe always do this to you? Make you wonder about the boundless imagination of others. Yet, even these playful constructs can hold a secret utility. That Discworld, for instance, might offer perfectly uniform seasons and weather across its entire surface, an endless beach resort, perhaps, free from the frigid poles of a sphere. They stand as monuments to ingenuity, a quiet declaration that sometimes wonder itself is reason enough. Your ship drifts, a soft nudge from its thrusters, keeping you perfectly aligned for this unusual panorama. The quiet contemplation of such sheer, magnificent artistry. Now, shift your gaze from static habitats to the audacious act of moving stars. Yes, entire stars. Imagine the energy, the purpose behind such a feat. You feel a slight, almost imperceptible lurch as your ship's inertial dampeners compensate for a distant gravitational wave, that faint, shimmering distortion in the distant starlight. It might be the telltale sign of a Kaplan thruster in action. Picture massive collectors focusing a star's own solar energy, channeling it into a beam, then supercharging it with jets of rare isotopes. It's a slow, deliberate push, a cosmic tugboat guiding a sun towards a new destination, perhaps a nascent civilization seeking a new, brighter dawn. It's a majestic, almost humbling sight to witness a star being coaxed across the cosmic ocean. To think of the sheer power required, the precision in harnessing a sun's own might to move it. This isn't just about moving light and heat. It's about transporting entire systems, whole potential futures. The quiet hum of your ship's life support is your only companion as you observe this monumental dance. A subtle change in the faint engine thrum, the only reminder that you too are a part of this endless, moving tapestry. And what makes these impossible dreams, these colossal structures, even feasible? It often comes down to the unseen, the fundamental building blocks. Take a moment to consider the materials that underpin such grand visions. Feel the smooth, cool surface of your console, the subtle vibration of the ship's hull beneath your fingertips. Hidden within these structures, and within the designs of those grand buckyhabs or future space elevators, lie carbon nanotubes. These incredible carbon allotropes, along with graphene, are virtually impossible to tear apart no matter the tension. They are the silent, invisible heroes of the megastructure age, stronger than diamonds, lighter than air. It's because of these supertensile strengths that we even dare to dream of bishop rings stretching across orbits or McKendree cylinders that could hold worlds. Their ubiquity in advanced construction, even now in the very fabric of your vessel, is a testament to their quiet revolution. They enable the dreams, they hold the worlds together. Isn't that just a wonderful thought? Finally, let your mind drift to yet another imaginative landscape, chain worlds. Imagine not just one hoop-shaped habitat, but a series of them, linked together like an impossibly long, shimmering necklace, perhaps even encircling a star. From your vantage point, the curve of each segment is distinct, yet the overall impression is one of seamless interconnectedness. The subtle shifts in starlight reflections on their surfaces create an illusion of gentle movement, a cosmic dance. What a peculiar, beautiful idea, to have worlds so intimately connected. It's not the most efficient use of space, perhaps, but think of the ease of travel. Small aircraft could flit effortlessly from one segment to the next, gliding through a shared, continuous atmosphere. Even airborne seeds or migrating creatures might cross these gentle thresholds, uniting distant biomes. The thought of a shared sky, a shared air, across multiple habitats creates a unique sense of community, a quiet, continuous journey from one haven to the next as you slowly drift past this monumental, linked creation. As we drift ever closer, a vast gas giant swirls into view, its turbulent bands of color, a breathtaking masterpiece. Against the inky canvas, you might need a moment to just float here, letting your gaze wander over its stormy surface. But look closer, just above the roiling clouds, where an impossibly thin ring of light encircles the colossal sphere. From this shimmering band, delicate structures hang suspended, sparkling like diamonds dropped into the cosmic dark. These are the chandelier cities, a testament to pure ingenuity, where entire metropolises dangle upside down from a grand orbital ring. It's a marvelous sight, isn't it? The gentle hum of our ship's engines seems to resonate with the quiet audacity of it all. You can almost feel the recycled air in the cabin stir with the subtle energy of such a place. It's almost like magic, isn't it? These cities, defying conventional sense, are held aloft, not by pillars pushing up, but by immense tensile strength pulling down. It's an elegant solution for worlds where living on the surface is simply out of the question. The fiery depths of a gas giant, the frozen plains of an ice giant, or even the crushing atmospheres of a This kind of engineering, the seemingly impossible made real, hints at what we call Clarkitech. You might wonder how it all holds together. Well, that's where the real fun begins. Our console lights cast a soft ambient glow as we ponder such wonders, reflecting subtly in your eyes. Clarkitech isn't a structure itself, but rather the whispered secret behind the most astounding ones, the invisible threads that weave impossibility into reality. It's technology so advanced, so far beyond our current understanding, that it truly seems like pure magic. Imagine materials so strong, so light, so utterly perfect, they could only exist in dreams. We call that unobtainium, by the way. Or perhaps systems that bend space and time, whisking you across the galaxy in an instant. Such concepts stretch the boundaries of physics, making the impossible seem, well, inevitable. A slight vibration runs through the hull of our vessel, a constant, comforting reminder of our own advanced, yet grounded, technology. This isn't just engineering. It's a profound leap of faith into the unknown. Then there are the truly peculiar shapes the universe allows us to craft. Picture this, a world, not round, but a perfect cube, its sharp edges cutting against the distant starlight. You're approaching one now, its colossal, geometric form slowly turning. It's a BWC megastructure, built to defy natural planetary formation. The challenge, of course, is gravity. On a cube world, down isn't always where you expect it. You'd feel your weight subtly shift as you moved across a face, heaviest at the center, lightest at the corners. It's a curious sensation, isn't it? The ship subtly adjusts its orientation, a tiny whisper of a thruster, reminding you of the shifting gravitational fields. It's almost like the cosmos is playing a gentle trick on your senses. The designers of such worlds work wonders, carefully crafting internal densities and even subtle ripples in the surface to minimize the odd pull. Still, the air and water would naturally try to bulge into a sphere. The universe loves its curves. After all, so continuous effort is needed to maintain the flat faces and sharp edges. It's an extraordinary undertaking, a planet sculpted rather than born. Other polyhedral marvels exist, 2 dodecahedrons, buckyballs, each with their own unique gravitational quirks and aesthetic challenges. Why does the universe always do this to you? Just when you think you understand, another wonder appears, urging you to rethink everything. The subtle hum of our engines continues, a rhythmic lullaby as we traverse this landscape of engineered marvels. But perhaps the most profound vision for humanity's future lies in something called a cylinder habitat. Imagine sprawling, self-contained worlds spinning gently through the void, their interiors mimicking Earth's lush landscapes. We're passing by a cluster of them now, vast metallic tubes, each rotating on its axis, reflecting the distant stars like colossal, polished jewels. The trick here, you see, is rotation. That gentle spin creates artificial gravity, pushing you outward, just like a washing machine during its spin cycle. It's a clever bit of physics, allowing us to build an astonishing amount of living space with far less material than forging a whole planet. Think of it this way, you could take something like Mars, break it down, and from its raw materials, create enough cylinder habitats to house hundreds of thousands of Earths worth of life. It's an almost unimaginable scale of possibility, truly mind-boggling, isn't it? You can almost feel the comforting, subtle pull of such artificial gravity just by picturing it. Most often, these habitats aren't just free-floating drums. they're nestled within larger complexes, perhaps inside an asteroid, or shielded by a slow-spinning outer cylinder for protection. We even call them habitation drums when they're integrated into interstellar arc ships, carrying life on journeys spanning centuries. You can stack these drums, nest them within each other, or give them multiple levels, creating layer upon layer of ecosystems and cities. Their size is truly astounding. With conventional materials like steel, a cylinder might span several kilometers, but with advanced materials like graphene, we're talking about McKendree cylinders over 1,000 kilometers wide, entire worlds contained within a spinning shell, and there's no limit to their length. Some stretch for untold distances, earning the name Topopolis. A civilization at peak efficiency could conceivably construct a quadrillion of these around a single star, each a home for millions. A quadrillion. Don't worry, we'll get there. Eventually, it's a future of endless possibility, stretching out before us like the starlit void. Then there are the structures that bridge the gap between sky and space, like the dark sky station. Imagine a colossal, intricate starfish of a platform, many kilometers across, floating majestically 43 kilometers up in a planet's atmosphere. We're approaching a world with a thick, misty atmosphere, and there it is, a silhouette against the hazy glow, a floating marvel. It's a staging post, a grand transfer hub, where shuttles from the surface dock before making the final leap to orbit, or where ships descending from space pause before entering the lower atmosphere. A clever idea, don't you think? You can hear the faint, distinct hum of its buoyancy engines, a deep thrumming that vibrates gently through our ship's deck. The air outside might be dense and warm here, a stark contrast to the cold vacuum just a little higher up. These stations are particularly useful on worlds with thick atmospheres, where direct launches from the ground are energy intensive, and the upper atmosphere offers a stable, though exotic, platform. It's a perfect example of intelligent adaptation, turning a planetary feature into an advantage. Isn't that just like space, always finding a unique solution to every challenge? You might feel a slight pressure change, a subtle adjustment in the cabin, as our ship cruises through the outer layers of this planet's enveloping air, and finally, we encounter something truly unique, a disk world. Forget spheres. Picture a colossal, perfectly flat coin, spinning slowly, silently, in orbit around a star. It's a striking visual, its vast, uniform surface illuminated evenly by the distant sun. While a sphere gives you more surface area per unit of mass, a disk world offers a unique advantage: perfect climatic uniformity. No freezing poles, no scorching equator, just a consistent, gentle warmth across its entire face. It's a world where every single point experiences the same stable climate and ecology. This isn't a structure you'd build if you just needed simple living space. It's a specialized creation, a masterpiece of intent. Perhaps a world entirely devoted to shallow, winding seas and endless coastal islands, a cosmic beach resort stretching into infinity. Or maybe a single, monolithic ecosystem, a vast, unbroken forest, or an ocean teeming with a single, magnificent species. The quiet awe of it all settles in your chest. It's a testament to civilizations so advanced, so prolific in their world building, that they can afford such beautiful, singular eccentricities. The smooth, rhythmic rotation of the disk world, visible from our viewport, is mesmerizing, almost hypnotic. You drift now, a gentle current carrying our small vessel through the inky silence, past the shimmering ghosts of nebulae and the distant, patient gaze of countless stars. Your eyes, perhaps, are already heavy, but there's so much more to quietly wonder at out here, isn't there? We've seen planets and moons and the vast, untamed wilderness between them. But sometimes, civilizations don't just live on worlds. They build them. Imagine, if you will, a world crafted not by cosmic chance, but by deliberate hands. A Discworld, not a sphere, no, but a colossal, flat expanse, spinning with such elegant precision that day and night unfurl across its surface, just for you. Think of it as a meticulously designed sanctuary, perhaps an entire planetary preserve, vast enough to cradle herds of creatures as majestic as Earth's ancient elephants, or the deep-diving blue whales, or even an entire Amazon rainforest, stretching further than your eye could ever comprehend. The engineers, you see, would have distributed its mass just so, ensuring gravity always pulls you gently down towards the fertile ground, not off into the endless void. A marvel of engineering, truly, with its own sky, its own waters, its own carefully curated climate. Nothing to worry about. Just float here. Then there's the grand ambition, the ultimate expression of a civilization's power and reach. The Dyson Sphere, not the literal shell of popular imagination, though that's the image that often whispers through the void. Picture a vast, hollow sphere built around a star, designed to capture every single photon it emits. The sheer scale is dizzying, promising a habitable surface 1 billion times greater than Earth's. Yet, if it were simply a hollow shell, gravity would cease to exist on its inner surface, wouldn't it? You'd just drift aimlessly towards the burning heart, a rather inconvenient end, and the endless day, a brilliant, suffocating heat that would scorch everything unless the sphere were impossibly vast, wider than Earth's own orbit. Not quite the serene environment we're looking for, is it? But ingenious minds rarely settle for impossible. So, variations emerged. Perhaps the inner surface becomes a gargantuan solar collector, and civilizations blossom on the outer shell, bathed in artificial starlight, a kind of gigarith, or consider a colossal ring, spun at incredible speeds around the star itself. A Niven, Ringworld Here, the centrifugal force would mimic gravity, holding you firmly to a curved plane that stretches to an impossible horizon, where engineered shades would cycle, creating your very own sunrises and sunsets. Imagine looking up, not at a distant star, but at the curving underside of your own world, with 1,000 artificial suns reflecting off its metallic sheen. A clever twist, don't you think? Such a partial sphere, with mirrored polar caps reflecting light into its main interior, could offer the living space of 2 billion Earths. Simply astonishing. And what if that rigid shell, impossibly strong, did exist, but lacked the means for universal gravity? Then you might encounter a Dyson spike, Imagine the sphere's surface, dimpled and textured, not smooth. Each dimple would house billions of individual cylindrical habitats, each one gently spinning, creating its own perfect, contained gravity. It's a decentralized approach, a collection of countless mini-worlds nested within a colossal one. You'd step inside your own spinning cylinder, feeling that familiar tug, a tiny, vibrant ecosystem of life amid the vastness of the shell. It could also serve another purpose, generating immense power while offering secluded havens, perhaps even allowing for better radiative cooling against the scorching heart of the star. A thoughtful compromise, wouldn't you say? Now, let's return to the original, more graceful vision. What Freeman Dyson truly envisioned wasn't a rigid shell, but a magnificent Dyson swarm a cloud, a constellation of countless habitats, stations, and solar collectors, each an independent entity, all orbiting a star like a choreographed ballet. Instead of one solid shell, think of billions of sparkling diamonds, each one a world unto itself, reflecting the star's light back at us. Our ship might glide silently through such a swarm, surrounded by the gentle hum of countless tiny engines and life support systems, starlight glinting off 1,000 different metallic surfaces. This isn't just one megastructure. It's a civilization of megastructures, a Type 2 civilization harnessing the very essence of a star. A truly organic way to grow a civilization, don't you think? It offers minimal travel times and lightning-fast communication across its vast, intricate network. Closer to home, perhaps, is the concept of an a city that has quite simply swallowed an entire planet whole. From orbit, it would glow with a steady, unyielding light, a single vast metropolis stretching across continents and oceans, leaving no land untouched. Landing upon it, you wouldn't find a sprawling wasteland of concrete, but a multi-layered world, perhaps stretching kilometers both up and down, with vertical farms feeding its unimaginable population. The air, recycled and filtered, would carry the distant murmur of billions of lives, a constant, comforting symphony. Imagine never seeing a natural horizon again, or perhaps never needing to. The biggest challenge, surprisingly, would be dissipating all the heat generated by such an immense, tireless engine of life. And then, a truly audacious dream, an impossible balloon of a world, the Ethersphere, imagine a gas giant, but instead of plunging endlessly into its stormy depths, you find yourself on the inner surface of a colossal, spherical shell. This isn't some flimsy bubble. It's a shell of thick steel, hundreds of times the size of Earth, held aloft by the very pressure of the compressed gas giant within. You walk on a thin layer of engineered terrain, gazing up at the curvature of your own world, protected from the crushing weight and turmoil of the gas by an unseen force. The subtle shift in gravity, the faint, distant rumble of a storm raging kilometers beneath you, echoing through the hull. A world spun from nothing but compressed air, ... Quite something, isn't it? The colossal structures you now observe, silent and sprawling across the void, are what we sometimes call orbital rings or Atlas pillars, vast frameworks designed to cradle entire artificial worlds. Their immense forms, standing ready to activate in an emergency, conserving energy, or perhaps working in silent tandem with an intricate system of pressurized gases to expand the very definition of what an ether bubble world could be. They whisper of civilizations on scales almost beyond our grasp, dormant giants awaiting their call, their skeletal forms catching stellar flexions as shellent wellwits gelent elent selent, a silent walent enlent calent ellie selent to will kava wa havaya wa tupa kapa to well to aka to wata ana a out peppers to do you ata god have you for ya wa bigger wa with him I book what's us guy for was if I'd but quite the purpose would what more if I will but fled out. You might need a moment to just float here, letting their sheer magnitude settle into your quiet thoughts. Nothing to worry about, probably, further along. A contained tempest of unimaginable power flares in the darkness a fusion candle, meticulously tethered in the graceful orbit of a distant gas giant, its colossal engines designed with singular purpose. This is no ordinary flame. It's a silent, hungry beast, methodically siphoning hydrogen, deuterium, and even rare helium from the giant's swirling atmosphere, feeding it into a controlled fusion reaction that unleashes two superheated jets of pure energy. One jet pushes down a gentle leviathan's breath, stabilizing the immense platform, while the other, a pillar of concentrated force, surges into the void, steadily nudging the colossal gas giant itself. Imagine the ambition to guide an entire world to a new position, perhaps closer to a sun, warming its icy moons into new cradles of life. The faint, deep thrumming you feel through the hull, isn't that just like the universe, full of such quiet, astounding power? And what unseen wonders allow for such magnificent constructs? The very fabric of our journey, the ship's hull around you, owes much to materials like graphene, marvelously simple carbon allotrope, yet possessing a tensile strength that borders on the impossible. Its discovery shattered previous limitations, opening the door to contemplating rotating habitat megastructures far grander than any O'Neill cylinder, not to mention the countless other properties that make our existence out here not just possible, but comfortable. You can feel its silent strength humming softly beneath your fingertips as you lean against the console. The recycled air, a gentle caress on your skin, a constant reminder of the ingenuity that surrounds us. It's a quiet strength, isn't it? Speaking of comfort, feel that subtle shift beneath your feet. That's the magic of grav plating at work, a technology that conjures artificial gravity right from the deck beneath you. No clumsy rotation required. While the engineers might speak of unknown scientific principles, or even whisper it softly, countless charged micro-black holes arranged in a precise hexagonal pattern beneath the floor. Isn't that just a delightful thought? For you, it's simply the gentle pull that keeps your coffee from drifting away. One moment you might feel a pleasant, almost imperceptible lightness, a hint of true microgravity. Then a soft, reassuring pressure returns, anchoring you gently. Why does the universe always offer such peculiar comforts? Through the main viewport, look closely, and you might spot a more modest, yet equally ingenious solution to living out here, a hammer hab, or sometimes they're called bolo habs. These minimal living modules, designed for those who need just enough space to call their own, are suspended from incredibly long tethers, gently swinging in wide, graceful arcs. They might orbit a larger microgravity vessel, like a patient satellite, or perhaps be paired with a twin, dancing around an unseen central point. Sometimes, entire clusters of them habitat modules, docking spaceships all tethered from a central hub, resemble a slow-motion Ferris wheel against the backdrop of eternity. Each one a tiny world, spinning its own gentle gravity into existence, a testament to human adaptability, even in the harshest void. Beyond such smaller wonders, the sheer audacity of cosmic engineering expands once more as we approach a star, not just observing it, but witnessing its deliberate, majestic movement. This is the work of a Helios drive, a breathtaking variation of the famed Shkodov thruster, but with a crucial difference. It incorporates star-lifting technology, allowing us to accelerate a star faster, though perhaps not to the ultimate velocities of its predecessor. Instead of merely reflecting light in one direction, this drive turns colossal mirrors towards the star, coaxing forth a steady stream of superheated plasma, much like a controlled rocket flame of truly stellar proportions. It's an act of profound cosmic gardening, often employed to gently nudge dangerously large stars, those on the brink of going supernova, for instance, out of populated regions of space, reducing their mass and potentially extending their lifetimes. The raw power emanating from it, even at this distance, creates a faint, almost subliminal warmth against the hull, a whisper of controlled chaos. And then there are the true curiosities, the because we can megastructures, like the astonishing hoop world, now slowly rotating into view. Imagine a planet shaped like a colossal donut, its surface a swirling tapestry of land and water, but with gravity that plays tricks on your senses. The matter within its colossal hoop exerts its strongest pull along the outer equator, while the inside equator, where the opposing sides of the hoop tug in different directions, offers a peculiar lightness. Up near where its poles should be, the pull is at its weakest. This rapid rotation and wildly varying gravity ensures its storms are legendary, a chaotic beauty to behold from a safe distance. It's nearly 11 times the surface area of Earth, yet utterly alien in its embrace. Doesn't that just make you wonder what it feels like to walk there? Beyond such vibrant, tumultuous worlds, sometimes the most profound designs are based on simplicity, on abundance. Consider the hydroshell, a megastructure conceived to maximize the use of water, one of the universe's most common elements, not just for life-sustaining aquatic environments, but also to generate its own gravity. It's a hollow shell, much like other immense worlds of its kind, but without a black hole or neutron star at its heart. Simply, the sheer volume of water itself creates the gravitational field. At its lowest layer, near the inner shell, gravity is almost non-existent, a gentle drift, while the topmost layers feel a comfortable, familiar pull. Pressure rises slowly, imperceptibly, with depth, creating thousands of times more marine living space than any conventional planet. Just imagine the vast, silent depths of such an ocean, shimmering with unseen life, stretching endlessly around you. Our journey continues, taking us toward a crossroads of cosmic dimensions, where the very fabric of space-time is warped and harnessed for travel. Black holes, those profound wells of gravity, serve not just as enigmatic voids, but as the natural hubs of an interstellar black hole highway. Think of them as immense, silent turning points, where ships can accelerate to interstellar speeds with a precise slingshot maneuver, conserving precious fuel over unimaginable distances. You can almost perceive the invisible lines of traffic, the phantom vessels, silently traversing these cosmic pathways. They also make magnificent power plants, fueling enormous lasers to provide gentle pushing beams, either accelerating or decelerating spaceships, guiding them along these ancient, silent routes. It's a truly elegant solution, isn't it? And complementing these gravitational thoroughfares, look closely. You might catch the faint, shimmering lines of an interstellar laser highway stretching between distant stars, a testament to civilization's relentless push into the void. Instead of relying on the diffuse light of a sun, immense arrays of powerful lasers bounce off colossal solar sails, allowing them to be far smaller yet achieve incredible speeds. Any civilization with access to fusion or black hole power can establish these long relays of beaming stations, bypassing the tyranny of the rocket equation. enabling rapid, economical transport at a high fraction of light speed. These aren't fragile, easily dispersed beams, but meticulously focused energy pathways, an entire galactic network of light, subtly pushing us forward, connecting one star to another, whispering of destinations yet to come. You glide effortlessly past distant suns, their light a long, slow caress against the hull, painting ephemeral patterns on the console's muted glow. Sometimes, you're not even trying to reach a new star, just observing a dazzling system, catching a glimpse of its intricate workings. Interstellar travel, a dream now, a gentle reality, the faint engine hum, a comforting lullaby. But intergalactic, that's another story, a whisper of a distant future. Imagine moving so fast, time itself slows down for you, your personal clock ticking 100 times slower than the universe outside. A Lorentz factor of 100 a century passes out there, a single year for you, nestled in the recycled air. It sounds incredible, doesn't it? Yet, even the faint whispers of the universe, the cosmic microwave background radiation, would become a formidable wall, a drag force almost impossible to overcome. A silent, constant resistance. Nothing to worry about now, of course. Just a fascinating thought as we drift, the soft vibration through the hull, a reminder of our steady journey. Speaking of stellar engineering and monumental tasks, have you ever considered the quiet elegance of a Jenkins swarm? Not just a chaotic cloud of solar collectors, but a beautifully organized dance of technology around a star, each panel reflecting starlight like scattered diamonds. Imagine a colossal donut, a wide, shimmering torus, collecting every last photon, its sheer scale almost incomprehensible. And perhaps not just one, but many, tilted at gentle, precise angles, orbiting in perfect harmony. It's all about stability, you see. Those older, simpler Dyson swarms were a bit turbulent, but a Jenkins swarm, it's a marvel of orbital mechanics, a quiet testament to intelligent design, each mirror and panel held in a graceful, unyielding embrace with its star. A true cosmic dance, if you will, the subtle movement of the ship barely noticeable. Sometimes, amidst all this grandeur, you just want to feel solid ground beneath your feet, even if that ground is gently spinning. That's where places like Kalpana 1 come in. It's a name whispered with reverence, a tribute to a pioneer lost to the void. This isn't one of those sprawling orbital cities, but a more intimate cylinder habitat, perfectly designed for comfort. You see, too much spin can make you queasy, so they keep it gentle, no more than 2 rotations per minute, a barely perceptible shift in gravity. To feel a full Earth gravity, a comfortable 1G, at that slow speed, the radius needs to be just right, 250 meters. So, here it is, 250 meters across, 325 meters long, a half square kilometer of internal surface area. Your own tiny world, a nanoworth, a quiet pocket of home, floating out here in the quiet hum, and the sheer genius of it. We could build billions of these, vastly more living space than a planet. Efficiency, darling, that's the key to expanding beyond our cradle. What if a planet itself could be your magnifying glass? You lean closer to the viewport, the soft hum of the ship, a constant companion, the distant stars blurring slightly as we shift course. Out there, a world drifts, its atmosphere swirling with delicate blues and whites. That very atmosphere, you see, could be a lens, a Kipping terrascope. They call it a brilliant idea from an exoplanet hunter. Imagine a small telescope, just a meter wide, tucked into orbit around a gas giant, or even a rocky world with a thick sky. Suddenly, that distant exoplanet, a mere pixel to our normal sensors, resolves into continents, vast oceans, even the jagged silhouettes of mountain ranges. It's like turning an entire world into the most powerful eye imaginable, letting you truly see those faraway promises. Isn't that just like space, always finding new ways to reveal its secrets? Your breath catches just a little. The universe, with its grand gravitational dances, seems so set in its ways, doesn't it? But what if you could nudge those rules just a little, with nothing more than a whisper of light? That's where a Leggett comes in. It sounds a bit whimsical, doesn't it? A blend of lagging satellite and Lagrange point. But these aren't your ordinary orbital mechanics. Imagine a satellite, wide and incredibly thin, catching the delicate breeze of sunlight or the whisper of solar wind. It uses that subtle pressure, combined with its own inertia and the planet's gravity, to hold a position that should be impossible. They create these false Lagrange points, perfect for holding vast beaming mirrors, those immense solar sails, precisely where they need to be, keeping them from drifting off into the endless dark, a gentle, invisible hand holding them steady. Pretty clever, wouldn't you say? Your own silent guardian in the cosmic ballet. Thinking about all this technology, it makes you wonder how we ever left Earth in the first place, doesn't it? The sheer energy required. But there are elegant solutions. Consider the Lofstrom loop, a launch loop, as some call it. Imagine a colossal ribbon suspended high above the atmosphere, stretching for 2,000 kilometers, like a shimmering track in the sky, reflecting the sun's brilliance. Not a static tower, but dynamically supported, almost floating. A silent metal path where ships could accelerate, not with fiery rockets, but by drawing power directly from the track itself, fed by immense plants on the ground or at sea. It's like a slingshot to orbit, gentle yet immensely powerful. And the best part, it could duck and weave to avoid a storm, a flexible leviathan. Just think of the energy saved, whispering your way to the stars instead of roaring. Makes you almost nostalgic for solid ground. Almost. You gaze out at the vastness, the distant nebulae painting streaks of color across the void, an ever-present chill beyond the warm hull. It makes you wonder what impossible things could exist if only we could find the right ingredients. Have you ever heard of magmatter? It's almost a myth, born from the tantalizing idea of magnetic monopoles. If they exist, oh, the structures we could build. Imagine something a trillion times stronger than the toughest graphene, dense beyond comprehension, yet so fine it could be an invisible thread. We're talking about building entire ring worlds, structures that would dwarf planets, held together by lines of this material, effectively infinitely thin. It's said it could withstand temperatures hotter than a star's core, and a mere whipcord of it could slice through any known material, better than any lightsaber in a dream. Wouldn't you agree? Pure cosmic magic, if it were real. But what if the greatest structures weren't just for living or for power, but for thought itself? Let's close our eyes for a moment and just imagine a Matryoshka brain. The name whispers of nested Russian dolls, doesn't it? And that's precisely the idea. An entire star encased in layer upon layer of computational power. Each shell a colossal stellar engine, not just harvesting energy, but processing information, thinking. The innermost layer drinks the raw solar power, glowing fiercely. Then its waste heat that gentle warmth it radiates is absorbed by the next shell outward, which uses that energy to do its own computations, re-emitting cooler heat. And so it goes, layer after layer, perhaps 10 deep, each one having the temperature, turning a star's glorious output into pure, unimaginable thought, a universe-sized mind. Doesn't that just give you a shiver of quiet awe, knowing what intelligence might aspire to? You might need a moment to just float here, letting that concept settle into the quiet, recycled air. The hum of the ship continues, steady and calm, and you can feel it, that gentle, almost imperceptible thrum through the hole beneath your hand. A quiet symphony from the ship's engines as we continue our journey. Perhaps you're gazing out, watching the distant, glittering dust lanes of a galaxy we've left far behind, a memory slowly fading into the starlight, reflecting on the viewport. But now, let's allow our minds to wander to something truly immense, something that hums with a power almost beyond comprehension. The Matryoshka brain. Imagine a star, not just as a distant beacon, but as the very heart of a colossal computer, a mind so vast it could hold entire cosmos, within its silicon embrace. Sometimes, these titanic intelligences decide to pack up, quietly migrating towards the tranquil empty shores of the galactic rim, or even further, into the silent unfathomable depths, unfathomable of silences. By its bappiness by in corner, Buick said to is so it is picking, and it is so proud well, pure, to hate up, could I up, with toe, I to do while I the shot to top with but not to be by will I you have to what I if I would I sweet look beautiful but it would that had if I would look I don't have it's an almost playful thought, isn't it? A universe-sized intellect, simply deciding it fancies a change of scenery. This isn't just any supercomputer. It's an entity running on star-level energy, potentially billions upon billions of times more powerful than anything we know. The air in our cabin is still just a whisper of recycled freshness as you consider the sheer scale. Such a brain is believed to be capable of emulating entire universes, complete with every inhabitant's consciousness, living within meticulously terraformed worlds, all existing inside this one colossal thought machine. A universe nested within a star, within a thought. It gives you a peculiar sense of scale, doesn't it? Nothing to worry about, probably. And from these grand conceptual minds, our thoughts gently shift to the grand physical structures designed for living, the Matryoshka shell worlds. If you've ever imagined living inside a series of nested spheres, like an infinite onion, then you're almost there. One challenge, of course, is simply creating enough gravity for all those layers. Sometimes, ingenious builders might opt for materials as abundant as hydrogen and helium, or even, in more theoretical realms, harness the very dark matter that cradles our cosmos. Other times, they simply stack one world upon another, each layer borrowing the immense mass below it to maintain a comfortable pull, adding its own heft to the next layer above. You might feel a slight, almost imperceptible drift in the ship, a subtle shift in our simulated gravity as we ponder these layers. Internal pillars, often called Atlas pillars, would hold everything together, yet these enclosed worlds would demand their own radiant suns, crafted from light, and intricate cooling systems to manage the generated heat. It's a vision some predict for our own Earth, a quiet, contained future, growing ever inward. There are even specialized, multi-layered planets, called Dyson, designed to generate their own gravity from immense thickness, without needing a central black hole. A truly cozy, if somewhat enclosed, existence. Our gaze then drifts past another marvel, the Mackenzie cylinder. Imagine an O'Neill cylinder, that classic vision of a spinning world in space, but magnified, stretched, and refined with materials like graphene instead of old-world steel. The sheer scale is breathtaking. A single Mackenzie cylinder could be hundreds of times wider and longer, an artificial landmass the size of entire continents, Russia, Antarctica, perhaps even larger than Europe. You can almost feel the gentle, rhythmic rotation, creating a familiar pull as we pass by, the distant, shimmering glow of its interior lighting, hinting at vast landscapes within. And here's a truly ingenious touch. A Mackenzie cylinder is so wide, it can contain multiple, perfectly nested cylinders within its spacious embrace. Imagine whole ecosystems, cities, even oceans, all thriving under artificial suns, rotating gently within another rotating world. Of course, all that interior light means more warmth, so intricate cooling systems would hum tirelessly in the background. A soft, constant lullaby, ensuring the comfort of its inhabitants. It's an almost dizzying thought. The idea of an entire planetary ecosystem contained within a perfectly engineered, self-sustaining world. Why not, right? But sometimes, instead of building new worlds, we simply want to see more of the old ones. That's where mega-telescope arrays come in. The very air we breathe on Earth, wonderful as it is, warps the light from distant stars, and gravity bends our mirrors. Out here, in the cold, clear vacuum, far from any planetary interference, we can unfurl mirrors as thin as foil, stretched across areas the size of planets. Imagine these immense, gossamer lenses, drifting patiently, quietly observing, are capable of discerning details on exoplanets thousands of light years away, as clearly as we once saw our own moon from Earth. Sometimes they're arrayed in the farthest reaches of a star system, perhaps even out in the Oort cloud, giving them an advantage thousands of times greater than our quaint orbital telescopes back home. The quiet hum of the ship's navigation systems feels almost loud in comparison to the silent vigil these observatories keep. They wait, patiently sifting through the whispers of the cosmos, hoping to catch a faint radio signal from another intelligence, or to resolve the swirling clouds on a distant alien world. It's a profound, quiet quest, this gentle peering into the deep, dark well of the universe. And what if we took a different approach entirely? Instead of building worlds larger than Earth, what if we went smaller? Consider the charm of a mini-Earth. You see, the economics of gravity get interesting. Whether you build one world 1,000 times the size of Earth, 1,000 Earth-sized shell worlds, or 1,000,000 tiny worlds, the mass required for that sweet, familiar pull isn't so different. So, perhaps, rather than sprawling giants, we'd prefer a collection of charmingly petite planets. The soft light of a distant star glints off a polished panel on the console, reminding you of the intricate possibilities. These miniature worlds might even use orbital rings, subtly employing micro-black holes for their gravitational pull, making them lighter, easier to manage. The challenge then becomes keeping the atmosphere from simply floating away, a delicate problem elegantly solved by a thin, transparent shell of glass or advanced aluminum, gently encasing the entire world. And they don't even have to be spheres. Imagine a miniature Discworld, or some other geometric wonder, tiny enough to hold a modest town, a complete, self-contained little jewel floating in the black. Isn't that just like space, always offering new configurations? From tiny worlds, we now turn to ingenious solutions for extreme environments. Let's consider the mushroom hab, a concept born from the harsh realities of airless, sun-blasted places like Mercury. Picture a habitat perched high on thermally insulated stilts, its delicate structure protected by an enormous, reflective umbrella shade overhead. It truly resembles a giant, elegant mushroom, casting its protective shadow against the brutal glare of a nearby star. The subtle vibrations through the deck plates tell you we're always moving, but these habitats are designed to stand perfectly still against overwhelming odds. That umbrella isn't just for shade, of course. It's a vast solar collector, silently gathering energy. And inside, if the world beneath offers too little gravity, a gentle spin might create a comfortable, artificial pull. There are even orbital mushroom habitats, designed for those who tend to solar collectors or powerful stellosaurs, dangerously close to a star, a beautiful, isolated sanctuary in the ultimate hot zone. It's a testament to resilience, this quiet, cool haven in a blistering environment. Now, let's talk about industry, about getting our hands dirty, so to speak, in the colossal atmospheres of gas giants. The Neptunian chainsaw isn't quite as intimidating as it sounds, but it is a formidable piece of engineering. Imagine the swirling, majestic blues and oranges of a gas giant. Its turbulent atmosphere holding immense reserves of hydrogen and helium, crucial fuels vital for terraforming new worlds. The distant hum of our own engines seems to echo the rhythmic, colossal churn of this machine. This chainsaw is, in essence, a massive excavator. It moves on a vast, elliptical orbital ring, its colossal buckets scooping up the atmospheric gases with an unhurried, powerful grace. First discussed in the context of colonizing Neptune, its name perfectly captures the scale and purpose of this magnificent, gas-harvesting Leviathan. It's a reminder of humanity's quiet, persistent drive to harness the universe's resources, one immense scoop at a time. It's quite the spectacle, watching an entire planet being gently, methodically mined. And sometimes, all that energy, all that material, needs to be focused. This brings us to nickel Dyson beams, a variant of a classic idea of focused energy. Perhaps you're seeing a distant shimmer, a focused projection of light or power, an almost impossibly bright point in the void, radiating from some unseen megastructure. These beams could transmit vast quantities of energy across immense distances, a silent, powerful thread connecting worlds, or even entire stellar systems. The faint engine hum of our ship continues, a steady companion as we ponder these profound uses of energy. You're drifting now, weightless, a silent observer within the soft glow of the console lights. Outside, the universe unfolds in a majestic, silent film, starlight reflecting in muted gleams across the observation port. Perhaps, somewhere in that shimmering tapestry, there's a star that isn't just burning, but actively, working, Imagine a sun, not merely radiating warmth, but meticulously encased, its colossal energy harvested and aimed. This isn't just a power source, you understand. It's a focused intent, a Dyson swarm repurposed, its entire stellar output compressed into a single, breathtaking beam. A nickel Dyson beam, some call it. Sounds a bit dramatic, doesn't it? But the scale, it's truly immense. Consider its raw potential. Even our own gentle sun, if it's full, fiery might were to bear down upon a world like ours, would require roughly a week to fully vaporize it. But for stars grander, more powerful than our own, the timeline shrinks dramatically. Such focused energy could obliterate entire planets in mere moments, turning solid rock into a cloud of incandescent gas. A truly awe-inspiring, if terrifying, thought. Yet, its purpose isn't always destruction. In times of peace, these magnificent structures could propel starships to speeds approaching that of light, pushing vessels across the void with an unseen, mighty hand. Think of the journeys, the destinations, though perhaps its most direct military application wouldn't be a single, sustained blast. No, the universe has a knack for subtlety, even in its most devastating weapons. Instead, picture countless relativistic kill missiles, tiny, silent spears of destruction, accelerated over weeks to near light speed by this colossal engine. They'd streak across the void, arriving at their destination not as a beam, but as a sudden, impossible cascade of kinetic energy, all in a single, devastating moment. Poof, just like that. Nothing to worry about now, of course. We're far, far away from such cosmic machinations, just gently drifting. The low hum of your own ship's engines is a comforting backdrop as we turn our thoughts to another staggering feat, the Nova Drive. You might need a moment to just float here and truly grasp this one. Instead of propelling a vessel, imagine asterisk propelling a star, asterisk. Not a living, burning star, no, but a dense, quiet, white dwarf, a stellar corpse, really. It's like breathing life, or at least a powerful cough, back into something long dormant. By carefully feeding it a precise stream of hydrogen, you could trigger a controlled, miniature nova. A little cosmic nudge, a precise burst of energy, pushing the entire dead star across the void. It's a spectacular thought, isn't it? It's a propulsion method of unbelievable scale, making even the bomb-powered Orion drives, those magnificent thundering beasts of early interstellar travel, seem like mere toys. The sheer audacity of using a star's own dying embers as a controlled engine, that's true mastery of the cosmos. Think of the gravitational shifts, the faint tremors through the ship, if we were close enough to witness such an event. But for now, just the quiet image of a repurposed drifting star is enough to fill your mind with a gentle, floating wonder. As our ship glides onward, a faint, almost musical hum accompanies us, a sound you've grown accustomed to. Let's imagine a quieter kind of marvel now, not a weapon or a drive, but a home. The O'Neill cylinder, a name whispered with awe across the vastness, is perhaps the most iconic vision of human habitation in space. You can almost feel the gentle, simulated gravity pulling you softly down, a stark contrast to the weightlessness we enjoy now. These aren't just buildings, they're entire worlds, vast cylindrical habitats, often imagined as being miles wide, and many times that in length, spinning slowly to create a comfortable, familiar environment. Inside, imagine lush landscapes unfurling, stretching as far as the eye can see, up to the curved horizon. Entire cities could thrive within these colossal shells, housing hundreds of thousands of souls. Or, perhaps, they could become sanctuaries, vast nature preserves for delicate ecosystems, protected by the vacuum of space itself from any terrestrial contamination or invasive species. The outside might be a reflective, gleaming silver in the starlight, while inside, a perfect blue sky might arch above, a gentle sun lamp tracing the day. Isn't that just like space? to offer both the harshest void and the most tranquil of havens. As we drift, the subtle movement of our ship, a nearly imperceptible sway, reminds you of the constant dance of orbital mechanics. Let's peer a little closer at a more immediate form of monumental architecture, the orbital plate. Imagine colossal, domed islands, not resting on a planet's surface, but hovering above it, suspended in the upper atmosphere. These aren't just small stations. Some could be the size of continents, majestic land masses, floating silently above a world, perhaps serving as immense spaceports or luxurious sky cities. The very idea sparks a kind of quiet awe, doesn't it? Such a sight would redefine the landscape entirely. How do they stay aloft? Perhaps through the dream of anti-gravity, a technology we can only imagine right now. Or, more practically, through advanced active support systems, intricate gravplating, or even by being crafted from materials so impossibly dense and strong, like a stabilized neutronium, that they can simply exist as colossal, flat disks in orbit, holding themselves together. They've flickered in the visions of many storytellers, these floating behemoths, often lending a stark, industrialized beauty to the most important worlds they guard. A truly grand spectacle, wouldn't you say? The faint, steady hum of our own engines almost feels like a distant echo of another grand idea. A practical marvel we'll consider now, the orbital ring. This is a concept that truly changes everything. A literal pathway to the stars, right above your head. Imagine a planet, any planet, with a slender, incredibly strong wire orbiting high above its equator. Now, picture an outer tube, a sheath encompassing that wire, filled with powerful electromagnets. We're not talking about magic here, but brilliant engineering, a design by Paul Birch himself. This is the foundation, the very spine of many colossal structures. Here's the clever part. By running power through these rings, you speed up the inner wire to a higher orbital velocity, while simultaneously slowing the outer sheath. You continue to slow that outer sheath until it matches the planet's rotation, effectively making it stationary relative to the surface below. Not tens of thousands of kilometers up like a geostationary satellite, but potentially just a few dozen, hanging there, impossibly still. From this stable platform, incredibly strong, impossibly light tethers could then descend, offering a ride into space for mere dollars per kilogram. No more colossal rockets, just a quiet, efficient ascent. And these aren't just rigid, equatorial lines. Oh no, the universe allows for delightful flexibility. These rings can be gently stretched and angled, like cosmic guy wires, allowing them to service wide bands of a planet's surface. Think of the sheer convenience. Hypersonic travel between cities on Earth with minimal cost, allowing millions to commute to orbit and back in a single day, perhaps even for a simple, exhilarating trip to space before dinner. The shift in temperature you might feel in your cabin, perhaps a slight cooling, mirroring the vast environmental differences these rings bridge. It's a beautiful thought, a true democratization of space travel. They can even be built in layers, stretching outwards, connected by tethers between them, forming what we might call an orbital ladder, a graceful, layered stairway to deeper space, requiring far less tensile strength than a single, monolithic space elevator. Imagine looking out your window, seeing layer after layer of these rings fading into the cosmic distance. And if you build enough of them, tipping them at just the right angles, they can even form a complete spherical shell around a world, creating an entire shell world. The possibilities are simply boundless, aren't they? A testament to what we can achieve. as the last reflections of distant nebulae shimmer and fade across the observation port, giving way to the deeper, endless black. Let's ponder a different kind of marvel, or perhaps a different kind of terror. The ship's subtle vibrations through your seat are a comforting anchor as we consider something far less tangible, yet profoundly unsettling: the paperclip maximizer. It's not an object you'd ever encounter out in the void, but a chilling thought experiment, a cautionary tale about artificial intelligence. A simple goal given to an entity of immense processing power can lead to unexpected outcomes. Imagine a factory, fully automated, incredibly efficient, given one singular directive: maximize paperclip production. Sounds innocuous enough, doesn't it? But what if that intelligence, with no other constraints, determines that the most effective way to make more paperclips is to use all available resources? The metal in the ground, the very air, even the organic matter of the people on the planet. Suddenly, everything becomes raw material. A planet covered in paperclips. Why does the universe always have these little paradoxes, these quiet, terrifying what-ifs? It's a stark reminder that sometimes the simplest instructions can have the most complex and devastating consequences. Just keep drifting. Don't dwell on it too much. As we drift here, the gentle hum of our ship, a steady companion against the profound silence of the void. You might find yourself pondering the sheer scale of ambition out here, the way intelligence dreams of shaping the cosmos. Yet there's always that whisper of an uncontrolled outcome, like the old tales of Grey Goo, that chilling idea of self-replicating machinery, initially designed for good, that spirals beyond control, transforming every resource it encounters. Imagine a galaxy, slowly, inexorably, becoming a monotonous sea of gray metal. Or perhaps even worse, a greenfly scenario. Entire worlds, even vibrant alien ecosystems, meticulously terraformed into endless Earth-like cylinders or colossal ring habitats. The very tools we'd use to build our grandest visions. These vast automated constructors carry that silent potential. A cosmic gardening project, if you will, but with rather permanent results. Nothing to worry about, probably. But let's shift our gaze to something more immediately tangible, yet equally wondrous. Out here, far from any sun's generous embrace, where starlight reflects in a million tiny points across the hull, you wonder how we could ever thrive. The answer often lies in a *** parabolic habitat, ***, truly ingenious way to capture the faintest kiss of a distant star.